Okay, welcome back students. Today we shall discuss about PPT 18, that is our session 18. In this PPT 18 or session 18, we are going to study the FM frequency modulation demodulator. So demodulator is the process of separation of low frequency message signal from high frequency signal. FM demodulator means from the frequency modulated wave you will get message signal. This message signal variation is according to the variation of frequency in the FM wave. So we know that what is FM wave? FM wave consists of frequencies, that is FC, normal carrier frequency. This corresponds to zero amplitude of modulating signal, and this is for positive peak value you get FC plus delta F, and for negative peak value you get FC minus delta F. So the frequency of FM modulation changes from FC minus delta F to FC plus delta F depending upon the variation of this message signal, amplitude of the message signal. For maximum peak value you get maximum deviation, that is FC plus delta F. For minimum peak value you get minimum frequency, FC minus delta F. Where the amplitudes are zero you get same frequency, FC. So now demodulation is the process of conversion of this change in frequency into corresponding amplitude variations. That is, at the frequency FC you should get zero amplitude of the modulating signal. For this frequency you get positive value of the amplitude, positive amplitude of the signal. For this you should get negative amplitude of the modulating signal, that is zero, that is positive and negative. So this corresponds to FC, this corresponds to FC plus delta F, and this corresponds to FC minus delta F. Thus this change in frequency is obtained as amplitude variations. This is our demodulations. These demodulations can be obtained by means of balanced slope detector. So balanced slope detector. This balanced slope detector is used to demodulate the FM frequency modulated wave. So frequency modulated wave, FM demodulation. I will write the circuit diagram here. The circuit consists of an input transformer, so T1 is the input transformer, and this transformer has a capacitance C. This L and C has a frequency FC equals 1 over 2 pi root LC. The input to this transformer is frequency modulated wave. So apply frequency modulated wave as input, get the amplitude variations in the output. That is our message signal. So conversion of this FM wave into sine wave is called demodulation of FM wave. How this FM wave is present? The FM wave consists of low frequency, normal frequency and high frequency, where amplitude remains constant as EC itself. So this is FC minus delta F. This is normal frequency FC. This is FC plus delta F. Therefore, this variation in frequency should be converted into amplitude variations such that you get zero amplitude corresponds to carrier frequency FC, and maximum amplitude corresponding to frequency FC plus delta F, and minimum amplitude, that is the negative voltage, corresponds to FC minus delta F. So let FM wave is applied through the primary of the transformer T1. Now the secondary of this transformer is exactly center tapped. It is center tapped such that the upper is tank circuit. This is one tank circuit. This is another tank circuit. Parallel combination of L and C is called tank circuit. This is upper tank circuit. This is lower tank circuit. Let this upper tank circuit be tuned to frequency Fc plus delta F. Let this lower tank circuit be tuned to frequency Fc minus delta F. Input is tuned to Fc. Upper transformer is tuned to Fc plus delta F. Lower transformer is tuned to Fc minus delta F. That is, when the input frequency to this is Fc plus delta F, voltage across this is maximum. When the input frequency to this tank circuit is Fc minus delta F, voltage across this is maximum. For all other frequency, the voltage is minimum. Therefore, first I will write Fc plus delta F and F. Let us consider the voltage of this transformer with respect to the frequency. Okay. Now you will get a curve like this. Say this is Fc. This frequency is Fc. This is left frequency. Call this as Fc minus delta F. To this right, call this as Fc plus delta F. So, this is the characteristics curve for the upper transformer because it is tuned to Fc plus delta F. Therefore, the voltage is maximum. Voltage is maximum only at Fc plus delta F, and below Fc plus delta F and above Fc plus delta F, voltage decreases. That is the characteristics of tank circuit. Here, this tank circuit is tuned to Fc minus delta F. Therefore, it has a maximum voltage for Fc minus delta F. And for all other frequency, voltages are minimum. See, this is the characteristics of lower transformer, tank circuit. It has a maximum voltage for Fc minus delta F. Below this, above this, the voltage falls. Now, this FM wave, after passing through this upper and lower transformer, you get AM wave. That is amplitude modulated wave. That is, this FM wave is converted into amplitude modulated wave. This is our amplitude modulated wave. Next, this amplitude modulated wave is then made to pass through a diode. This diode removes the negative cycle because the diode becomes reverse bias for negative value and becomes forward bias for positive value. Therefore, the output of diode is only a positive value. Output of this is again only positive value. Now, this consists of both message signal. This is low frequency message signal. Inside this is a high frequency carrier signal. Therefore, this consists of both FM plus Fc. Now, consider a capacitor in this manner. This C1 and C2 capacitor, what it does, this C1 removes the Fc here. This C2 removes, this is also FM plus Fc. This C2 removes Fc here. So, Fc and Fc from here is bypassed to this capacitor. Output of this is only a message signal. Output of this is only a message signal. When this message voltage signal is passed through a resistor R1, you get a voltage VR1. Similarly, another resistance R2. This message signal flowing through R2 produces voltage VR2. Between these two, you get the output voltage VO. This output voltage VO is VR1 minus VR2. This is because VR1 is upper side, VR2 is lower side. This is upper tank circuit, this is lower tank circuit. Whatever the voltage at this is negative value for the lower transition. If this is plus V, this is minus V. Therefore, you get a positive value here and you get a negative value here. Now, let us discuss the cases. Case 1. Suppose if the input frequency is Fc. See, if the input frequency of this FM wave is Fc, when this is Fc, it is tuned to Fc plus delta F, it is tuned to Fc minus delta F. Therefore, this Fc, what is the voltage? Mark the voltage here. This is the voltage for the upper tank circuit for Fc. This is the voltage for the lower tank. This is VR1, this is VR2. This is second circuit, upper tank circuit. This is for lower tank circuit. This is the voltage at Fc. This VR1 is equal to VR2 at Fc. Therefore, VR1 is equal to VR2. So, when the input frequency, first case, when the input frequency is equal to Fc, we have VR1 is equal to VR2. Therefore, the output voltage VO is equal to VR1 minus VR2. Both are equal at Fc. Therefore, this is 0. That means when the input frequency of the frequency modulated wave is Fc, output voltage is 0. Now let us consider another frequency, Fc plus delta F. When the input frequency is Fc plus delta F, since it is tuned to Fc plus delta F, its voltage is maximum. It is tuned to Fc minus delta F, but the incoming frequency is Fc plus delta F. Therefore, voltage across this is minimum. This is VR1, this voltage is VR2. Therefore, see this circuit. At Fc plus delta F, voltage of the upper tank circuit VR1 is maximum. Okay, is maximum. And for Fc minus delta F, this voltage is, so when the input frequency is Fc plus delta F, this is VR1 is maximum. This is for second curve, this is VR2. So at frequency Fc plus delta F, VR1 is maximum, VR2 is minimum. Therefore, second case is that when the input frequency Fin is equal to Fc plus delta F, we know that VR1 is greater than VR2. Therefore, the output voltage is VR1 minus VR2. VR1 is greater than VR2, therefore it is greater than 0. That is, output voltage is positive. Therefore, when the input signal frequency is Fc plus delta F, the output voltage is positive. That means it is a positive peak value. In the case 3, in the third case, let us consider the input frequency Fin is equal to Fc minus delta F. So see, when the input frequency is Fc minus delta F, this is tuned to Fc minus delta F. Therefore, voltage of this is maximum, voltage of this is minimum. See this circle. When the frequency is Fc minus delta F, this VR1, this is VR1, this is VR2. So, at Fc minus delta F, VR1 is less, VR2 is more. Therefore, the output voltage, that is VR1, is less than VR2. Therefore, output voltage VO is equal to VR1 minus VR2. Since VR1 is lesser than VR2, that is VR2 is more than VR1. It's a negative value. Therefore, the voltage is, that is less than 0. That is, voltage is negative. Therefore, when the input frequency is Fc minus delta F, the output voltage is negative. So, when the input frequency is Fc, output voltage is 0. When the input voltage is Fc plus delta F, the output voltage is positive, that is, it increases greater than 0. When the input frequency is Fc minus delta F, it is negative, output is negative. Thus, the change in the input frequency changes the amplitude variations at the output. This is our frequency demodulation by balanced slope detector. Thank you.